This video is going to give a really quick overview of how the odds ratio is derived in a logistic regression. So just a quick refresher, this is data that would be ideal for answering a logistic regression question. So both heart attack and sex are something we can code as one for, I guess in the case of heart attack, one would be outcome positive, zero is outcome negative. And we can arbitrarily assign 0 and 1 as male or female. So just for this case, let's just say 0 is female and 1 is male. So subject 1 is a female that had a heart attack. Subject 2 is a male that didn't have a heart attack. And in a logistic regression, we're able to use that data to get this logistic equation that very much like a linear equation has this intercept here that represents the baseline risk in the referent category. In the case of the example I said before, that would be the odds in females. And this beta 1 is the increased odds or decreased if this was a negative sign of being male, basically. And something we're told in epidemiology classes is just this kind of like magical thing where when you exponentiate beta, it becomes an odds ratio. But I thought it might be helpful to kind of describe how that is. So just to set the stage here, like the question we were asking just for the sake of this example is the probability, or what's the probability of lung cancer given you're a smoker? And basically we're able to get a measure of effect that's an odds ratio to make some statement like the odds of lung cancer is 2 times higher if you smoke. And just a review of what an odds ratio is, it's the odds of disease among this exposure group, so the smoking group, over the odds in the non-smoking group. So an odds is the number that are outcome positive over the number that are outcome negative among the smoking group. So that's 40 over 10. And then the denominator is the same thing for the non-smoking group. And it is a ratio of the odds, an odds ratio. So the fact that it comes out to 2 tells us that if you're a smoker, you're 2 times more likely to have lung cancer than a non-smoker. So just to kind of reiterate what I was saying before, we have 0 and 1 representing 0 is female and 1 is male. And if x is 0 here and we plug that in, that cancels and we're just left with beta naught here, the intercept, and that represents the baseline risk if you're female. And if you're male, that would be 1, and basically your risk represents both terms, basically. It's like this initial one, and if males are at a higher risk, it would be this additional risk on top, and if they're at a lower risk, it would be subtracted from that female risk. So that lets us define beta 1 more explicitly as the, because it's logit, it becomes logit over here. So the probability of the outcome in males minus the probability of the outcome in females. And both of those are logit transformed. So because it's logit transformed, we can more explicitly write that is the odds of the outcome given that you're male minus the log odds, or sorry, yeah, the log odds of the outcome when you're male minus the log odds of the outcome when you're female. And that's what's saying here. Probability of y given x equals 1. That's the probability of the event given that you're male, given that x equals 1, over 1 minus the probability of that event. So that's the definition of an odds. And if you remember log rules from high school, when you subtract one log from another, you can have them as a ratio. So here we have the log odds of the outcome when x is equal to 1 when you're male over the log odds of the outcome when x equals 0. And if you exponentiate that, that gets rid of the log, and you're left with an odds ratio.